All right, let's dive right into this explainer. Today, we're taking a cosmic journey out to Caldwell 30, or as it's officially cataloged, NGC 7331. Now, at first glance, it looks like your classic, beautiful, serene spiral galaxy. But as we'll see once we peel back the layers of the astronomical data, this seemingly tranquil star city is actually hiding a wildly chaotic and even violent past.
To kick off our tour, we've got to travel an absolutely mind-boggling distance, 49 million light-years away from Earth. If you look up at the night sky right toward the Pegasus constellation, well, that's exactly where this magnificent spiral is hanging out. It's a massive distance, obviously, but thanks to modern telescopes, we can actually study it in incredible detail.
So here's our cosmic flight plan for today's explainer. We'll start with a welcome to Caldwell 30, explore the Deer Lake neighborhood, see how it's a Milky Way twin, learn about seeing the invisible, uncover the counterarm mystery, and finally dive into countabilism and tidal streams.
Part 1. Welcome to Caldwell 30. This majestic spiral acts as the absolute heavyweight anchor for a super fascinating region of space. Now take a look at the data table here. Notice that 70-degree inclination? That number is huge for astronomers. Basically, it means we're viewing this galaxy beautifully tilted. It's not completely flat edge-on, and it's not totally face-on either. That sweet spot 70-degree tilt gives us the absolute perfect vantage point to check out both its grand sweeping spiral arms and its dense glowing core all at the same time. It's almost like the universe posed it just for us.
Moving on to Part 2, the Deer Lake neighborhood. Zooming out just a bit, let's explore the sparse, filament-like space it lives in, commonly known as the Deer Lake group.
This map right here brilliantly illustrates the loose, extended vibe of this specific pocket of space. And when you look at it, Caldwell 30 is the undeniable heavyweight. It sits right in the center as the most dominant, luminous member of the subgroup. Surrounding it are these smaller, late-type galaxies, which just means they're active, gas-rich spirals. So compared to massive galaxy clusters, it's a relatively diffuse and empty neighborhood, but it's definitely not lonely. In fact, if you check out pretty much any optical photo of Caldwell 30, you'll spot these other galaxies completely photobombing the main event. Astronomers actually affectionately call them the fleas of the Deer Lake group. We've got lenticulars like NGC 7335 and 7336. Those are disk galaxies that have used up most of their interstellar matter, plus a barred spiral and an elliptical. Now, they might look like they're buzzing right around Caldwell 30, but they're actually background objects way further away. Still, they make for an incredibly spectacular visual.
All right, Part 3, a Milky Way twin. As we zoom back in, it's worth noting that astronomers frequently use Caldwell 30 as a sort of cosmic mirror to understand our own galactic home.
So here is the crucial takeaway. Despite being brighter than our neighbor Andromeda, and despite being considered a structural twin to the Milky Way, Caldwell 30 is missing something huge. It is mysteriously lacking large companion galaxies. I mean, our Milky Way has the massive Magellanic Clouds, right? And Andromeda has several bright dwarf elliptical companions, but Caldwell 30? It only has about 2% of the early type satellite mass of Andromeda. It basically has no older massive dwarf companions. It's shockingly empty around the edges. So you have to ask, why is this massive galaxy sitting all by itself?
Which leads us to Part 4, Seeing the Invisible. To figure out why this galaxy is so weirdly alone, and where its mass might have gone, astronomers have to look beyond visible light.
This really brilliantly illustrates the kind of multi-wavelength technique used in modern astronomy. When we look at the exact same object through different filters, say scanning for carbon monoxide or using far ultraviolet and infrared, that quiet, peaceful spiral completely transforms. Just look at the contour mapping here. It shows us that beneath the visible starlight, Caldwell 30 is hiding a complex, massive, dusty ring of really intense star formation right around its core.
But if you zoom in on that ring, the data reveals this massive, undeniable imbalance. The physics of the gas, the density of the dust, and the actual rate of star formation on the eastern side of the disk are just completely different from the western side. The eastern side has way higher physical parameters. It's totally lopsided. Now, a perfectly undisturbed galaxy, that should be relatively symmetrical. But Caldwell 30 is fundamentally off balance deep inside its gas clouds.
Part 5, the counterarm mystery. Let's look even closer at that inner structure and see how this builds into an even weirder mystery.
Okay, this is where things get truly bizarre. Detailed mapping of the molecular gas shows 5 main spiral arms. 4 of them are totally normal,
They trail along beautifully with the rotation of the galactic disk, just like you'd expect. But the fifth one, astronomers detected a counterarm that is running in the exact opposite direction. Think about that. One of its arms is literally moving backward against the traffic of the entire galaxy. You don't just get a backward rotating spiral arm out of nowhere. Something had to have violently disrupted this system.
And that brings us to the climax of our grand tour, Part 6, Cannibalism and Tidal Streams. It's time for some deep space forensics.
Notice those arrows pointing out on the western edge of the halo? They're highlighting a super faint stellar stream and a diffuse plume of stars. This was captured in an incredibly deep, contrast-enhanced optical view of the galaxy. And folks, this is the smoking gun. It's the exact visual evidence of a past tidal interaction. We are literally looking at a cosmic crime scene, confirming that this galaxy's weird internal imbalances and backward arms are the direct result of a gravitational collision.
As you can see from this survey quote, it heavily suggests that Caldwell 30 was, well, a pretty messy eater. Remember how we noticed it was missing those large companion galaxies? Turns out, Caldwell 30 likely cannibalized one of them. That stellar debris stream tells us it completely disrupted and shredded a smaller, gas-rich dwarf galaxy that just happened to wander a little too close to its immense gravitational pull.
So were there any survivors? Well, all that's left in the immediate vicinity of this giant are 4 incredibly faint dwarf spheroidal companions. You can see them isolated in these contrast-enhanced images labeled A, B, C, and D. These tiny, incredibly faint specks are the only surviving witnesses to the galaxy's violent history. They somehow managed to stay just far enough away to avoid being eaten by their massive host.
Which brings us to a really fascinating final thought. We started this explainer by looking at Caldwell 30 as this serene, peaceful twin to our own Milky Way. But knowing that even this quiet galaxy is hiding a brutal history of galactic cannibalism, asymmetric gas rings, and backward rotating arms, well, it leaves you wondering, doesn't it? What dark, violent secrets might our own galaxy's halo be hiding just out of sight? The universe is absolutely incredible, but man, it is rarely as peaceful as it looks from a distance.